Just recording a short video for you to help with the task that was set yesterday. There were actually two Heggerty tasks set yesterday. The first was expanding triple brackets, and the second one was dealing with algebraic fractions. So I'll take those one at a time, starting with the triple brackets. A couple of examples for you. So if you had something like 3 brackets next to each other, like so, and you had to expand them, what you would do is you would first of all expand this part of it using FOIL perhaps. I shall do that now. First, outer, inner, last. The next thing I would do is I would simplify this bracket here. So these cancel out and I get that. Then I would FOIL these two brackets. So first, outer, inner, last. I would now look through here to see if any cancelling can occur, and as it is, it can't. Simplifying rather than cancelling, I meant. We've got a cube term, we've got a squared term, we've got an x term, we've got a constant term. So we are effectively finished, although I would rewrite it in a slightly different order so that the powers of x are going down as I go through, and that would be the end of the question. We'll do another one of those. So suppose I had something like that to do. Doesn't look like a triple bracket until I write it out in full. And it looks like that. So again, I'm going to FOIL these two brackets. First, outer, inner, last, like so. And just like I did here, I'm now going to simplify this. Now, when you simplify it this time, unlike what happened before, where I ended up with just 2 things in the bracket, I've actually got 3 things in the bracket here. So can't really talk about using FOIL anymore, because FOIL works only when you've got 2 brackets with 2 things in each of them, like here, or here, or here. So I'm not going to talk about it in terms of FOIL anymore. I'm just going to think of it in a slightly different way. Perhaps if I explain with aid of a little diagram. Each of the things in the second bracket gets times by each of the things in the first bracket. So if I take the x in the first bracket, I've got to times that by the x squared, I've got to times it by the 10x, and I've got to times it by the 25. And as well as that, I've got to times each of the things in the second bracket by each of the other thing in the first bracket, which is the 5. So that's that, that, and that. The upshot of this is there are 6 different multiplications that I need to do. Let's do the red ones first. So that's x cubed, 10x squared, 25x. Now I'm going to do the black ones. So I've got 5x squared, 50x, and 125. So 6 different multiplications to do, and there they all are. Once again now I'm going to look through and simplify, collect like terms. So I can see I've got a pair of x squared terms here. a pair of x terms here. They're going to combine together to give me my final answer. So it's x cubed, just one of them. We've got 15x squared, 75x, and then plus 125 on the end. So that then is expanding triple bracket. So hopefully if you watch this video, it'll help you to try the ones on Hegarty Maths. Please do give it a go. Now, the other thing that I asked you to do was to do with dealing with fractions that don't just contain numbers but contain bits of algebra. This is something you're going to do a lot of at A level. So there are three real types of this. There's multiplication, there's division, and there is add and subtract, which is kind of the same thing really. Let's start with the easy one, which is the multiplication. If you have something like 5x over 11 multiplied by, for example, 33 over 7x squared, and you've got to multiply those two things together. All you have to do, just like you do for normal multiplication, is multiply the tops together and multiply the bottoms together to give the final answer. So it's that times that on the top, that times that on the bottom. However, and I'm sure Mr. Hegarty will have said the same thing, before you do that, you should look through and see if there's anything on the top that will cancel with something on the bottom because they share a common factor. For example, we've got an 11 here and a 33 here. Well, they share a common factor of 11. So I can divide the top and bottom by 11, and that will turn that into a 1 and that into a 3. Similarly, I'm also looking for any common factors with the letters. Okay, are there any common letters on the top and the bottom? Well, there are. There's an x on the top here, and there's an x squared on the bottom here. So they share an x. So I can get rid of an x from the top and get rid of an x from the bottom. Because there were effectively two x's on the bottom, x times x, I'm only actually going to get rid of one of them like that. Now all I do is I multiply the top, what's left on the top together, and multiply what's left on the bottom together. So the final answer would be 15 divided by 7x. Let's try another one. This time we'll do a divide. So if I had something like 10x cubed over, what should we have, 3 divided by, and let's have 5x over 12. There we are. So suppose we've got that to do. 10x cubed over 3 divided by 5x over 12. Okay, well, I'm not going to go straight to the answer this time, because if you remember from doing division of fractions, when there are numbers involved, there's a little rule. Some people call it the KFC rule. Not sure I'm a great fan of that. I'm a fan of KFC, obviously, but the idea of that sort of mnemonic, if you like. But KFC actually stands for keep, flip, change, and it's referring to what you do to this to turn it into a multiplication. You keep the first one as it is, you flip the other one upside down, and then you change the divide sign to a multiply sign. You change the sign. Keep, flip, change. Anyway, I won't go into the reasons why that works now, but it does work, and this is in fact the same calculation as this. So all I need to do this is remember what I did here. Very, very simple. I looked through to see if there was anything that cancelled. I'm going to start with the 3 and the 12, turn it into a 1 and a 4. I can do the same with the 10 and the 5. That becomes a 2, that becomes a 1. And I can do the same with the x's. There's an x there and an x cubed there, so I can get rid of that x there, and that turns into an x squared. So a bit messy, but if you look now, I've got 2x squared times 4 on the top, which is 8x x squared, and I've got 1 times 1 on the bottom, which is obviously 1, so the final answer to that one is 8x squared. Finally, I'm just going to do an addition for you. Okay, so addition works something like this. Suppose I had, for example, 7 over 2x plus, let's have, I don't really know where, 3x over, let's have 6. There we go. So we've got 7 over 2x plus 3x over 6. I'm going to add these two fractions together. Now, adding fractions together is only possible if they share the same denominator. These are the denominators here, and they are not the same. One of them is 2x, and one of them is 6. So what we are looking for is a common denominator. And whatever we choose, both of these things need to go into it. Okay, now, traditionally, the easiest way of finding a common denominator is to multiply the two bottom things together. And if I did that in this case, I could use for my denominator 2x times 6, which is 12x. So that would be an acceptable common denominator for this question. However, I should be looking for the lowest common denominator. Remember, both of these things need to divide into whatever I choose for my common denominator. Well, clearly it's going to have an x in it, or this is never going to divide into it. But I don't need 12x. 6x will actually do. So, if I make them both 6x on the bottom, what I have to do then is I have to look to see what I've done to each of the original denominators to get the new denominator, and apply that to both the top and the bottom of the fraction. So in this case, to go from 2x to 6x, I've had to multiply by 3. So I must also multiply the number on the top by 3, which is going to give me 21. Similarly, over here, to go from 6 to 6x, I must have multiplied the bottom by x. So I must also multiply the top by x as well, which means that 3x is now going to be 3x squared, like so. Finally, to add them together, I literally add the tops together, which is 21 plus 3x squared. I can't do any more than that. That's what I have to write. And I just put it all over the common denominator, and it's done. So, that's how you work with fractions when there is algebra involved. And that is how you multiply out triple brackets. Please try and do the Hegarty tasks, having watched my video. If you are struggling, you can always send me a comment, and I will get back to you very, very quickly with some help.